For the layman, good splitters are for refining and bad splitters are for expanding. And strong normalization ensures the resulting logical formulas are sound. Would you agree?
Thank you for the question. So a splitter of a formula is basically a formula with some additional assumptions added to it. And a good or a bad splitter, they both mean that we added assumptions to the formula, but they differ in the way that we did it. So in layman terms, I guess, when you add information to the formula that is meaningful to the formula itself, we call it a good splitter. And if you add, let's say, artificial assumptions to the formula, then it is a bad splitter. In logical terms, the Tau language, we have uninterpreted constant symbols. And whenever we cannot find a way to add more assumptions to a formula, we take a new uninterpreted constant symbol and assume that it is equal to 0 or unequal to 0, for example. And then this we add to the formula, and therefore adding an assumption. But in a sense, the splitter doesn't say anything related to the formula. This is why I said earlier that this is a bit artificial and not necessarily meaningful to what the formula says, but logically correct. Now turning to the strong normalization algorithm, it basically is a pre-processing step on the formula such that it is easier to decide how to add an additional assumption. So after a formula has run through the strong normalization process, we can be sure that adding certain assumption is actually really adding assumptions and not just adding information that is implied by the formula already. For this reason, the strong normalization is a pre-processing step that eases splitter computation. I think that's a good way to view it.